Welcome, everyone. Thanks for joining us today as we discuss migrating Exadata workloads to AWS. Please note this session is being recorded, so if you have any questions, please use the chat function and remain on mute. All right, next slide. So our agenda is going to cover three key topics as it relates to complex Oracle Exadata workloads. Number one is going to be the licensing, infrastructure options on AWS, and then the best practices to consider when migrating large, complex Exadata Oracle workloads to AWS. Next slide. So with me and joining me today are Peter Santos and Satya Desai from AWS. Currently, this is Mihir Patel that's speaking. Peter is the Senior Manager of Database SAs at AWS, and Satya is the Database Migration Modernization Specialist at AWS, and I am the VP of Cloud Architecture here at Apps Associates. So let's talk about Oracle licensing and what we need to consider when migrating off of Exadata's into AWS as it relates to Oracle licensing. Next slide. So as with any software asset, your Oracle is a sizable investment in your enterprise. And as such, you want to manage it effectively. So what does that entail? You want to understand what you're entitled to use, what you have deployed, and what you need. When you migrate this asset to AWS, you need to understand what the rules are and how to effectively manage that in AWS. AWS has tremendous services like AWS License Manager that can help you in that process once the workloads are migrated to AWS as well. But an effective software asset management strategy is always a good stance to take as it relates to Oracle licensing. Next slide. So what are the customer challenges that are faced whenever migrating workloads to cloud, right? What are customers concerned about, fearful of, et cetera? Number one is cost, not only of the licenses and the software assets, but also, what the cloud may introduce into their ecosystem and whatnot. What is that going to do from a total cost of ownership, impact to support, and things of that nature? So we'll help you navigate those questions, right? What do I have deployed? Is what I have deployed from an Oracle software license perspective fully utilized? What will it cost to run on AWS? We'll optimize that for you as we go through this. Licensing, the key questions customers have is, what can I do with my existing Oracle database licenses? Can I run them on AWS? Are they supported? How much is fully utilized on my existing? What we often find with Exadata customers is that they're over provisioned, not only from a hardware perspective, oftentimes, but also from a licensing perspective. Do they even need Enterprise Edition for some of the databases that are running there? As we do an assessment for you, we can evaluate what the right licensing model for certain systems and databases are to help you optimize your spend as it relates to Oracle licensing. And then from a migration perspective, which workloads can I move first? Which one should I move first? What are the skill sets that are needed to move and execute that? We can help you navigate that through a program that apps that will help you through that, which is called Optimization License Assessment. If you have questions on that, there'll be a link at the end where you can refer to. And in this process, through the Optimization License Assessment, will help you right-size your environment, help you understand your Oracle licensing better, and then what the AWS services are that you could employ to help improve your TCO. Next slide. So let's touch on briefly the Oracle licensing in the cloud policy. You have your contracts, and a supplement to that, for educational purposes only, Oracle has published a licensing Oracle software in the cloud computing environment guide. And in that guide, it basically states that we can essentially run our Oracle software in hyperscalers like AWS. So we can take our existing software assets and employ them into AWS, not a problem. The thing that document describes is that how to count licenses or compute capacity. So the key elements of that document are, whenever we're deploying Oracle licenses in AWS, 2 vCPUs are equivalent to 1 processor license. So if you have proc licenses, 2 vCPUs are equivalent to 1 processor. Now that equates to, if you have NUPs, that's 25 NUPs as it relates to the database. And then 1 vCPU is equivalent to 1 processor license if hyperthreading is not enabled. And then the core factor is not applicable whenever we're using shared instance types, EC2, RDS, et cetera, in a shared model. If you have a dedicated host, then you can do potentially use the core factor table if you have the dedicated host, but predominantly most customers are finding that EC2 and RDS is sufficient for in a shared deployment topology and counting those vCPUs. Next slide. So once you know what you own, what your options are in AWS in terms of the different licensing models that we could use and how to count them, let's walk through the different deployment scenarios. You can use EC2, where it's essentially a virtual machine and you get to manage everything on there. You get to decide what operating system to use. You can manage everything yourself. Then we have an offering for RDS Custom, where some of the capabilities of that compute infrastructure are managed by AWS, and you still get access to the operating system. You still get to select which operating system, those types of things. Or you can go to a fully managed database with RDS. So where AWS takes care of all of the OS installation, patching, database patching, backups, HA scaling, everything is managed for you in a managed service. And it's fully managed by AWS. So you have your choice when it comes to deployment scenarios as to how to take those licenses and employ them into AWS. Either manage it the same way you have been, or let AWS manage it for you. And there's 2 different licensing models that we'll talk about next. Next slide. So in AWS, there's 2 licensing models. We can do BYOL, or license included. Now, BYOL means bring your own license. And those are all based on the different types of contracts or license entitlements that you have. They can be granted from individual contracts for purely your proc licenses, your NUP licenses. You could have an enterprise license agreement, an unlimited license agreement, or perpetual unlimited license agreement. All of these contractual arrangements with Oracle from a licensing perspective allow you to employ those assets into AWS. There are different rules that may govern that, and we can help you navigate through that. But essentially, your licenses and the investment you've already made on those licenses can be deployed into AWS in what's known as BYOL model. An alternate to that would be a license included model. So in AWS, we can run RDS for Oracle with standard editions. If you don't have any Oracle licenses for standard edition, not an issue. We can still deploy standard edition into AWS with RDS. So you don't have to buy any licenses from Oracle. You just launch the service from AWS, and the license is included as a part of that service. And there's a great white paper for best practices for running Oracle databases on AWS to help you determine what's the optimal database, enterprise edition, standard edition, et cetera, for your enterprise. All right. And on that note, I'm going to hand it off to Satya, who will talk about the infrastructure options on AWS.
Thank you so much, Mihir, and thank you all for attending. What I'd like to do in this section is focus on the infrastructure details and the reasons why you should consider migrating away from Exadata. Next slide, please. So when we run Exadata databases on-prem, we're concerned about the routine maintenance. We're concerned about upgrading those Exadata software. We're concerned about ensuring that we're matching the Exadata stored software with the database software, with the underlying operating system. We're concerned about backup and recovery, failing over for an Exadata to another similar like-for-like Exadata using Active Data Guard. And all those tasks add to the overall burden of managing an on-prem monolithic database. When we're running on a fully managed database service like AWS RDS, we're not concerned about the automatic failover. We're not concerned about backup and recovery. We're not concerned about patching those databases and scaling them, trying to find room inside an Exadata that's triple mirrored doesn't have to be a cause for concern. What we're doing essentially is allowing your team to focus on value add tasks like schema design, like app development, like query optimization. And all that adds to the capabilities that your team has to gather data from the underlying infrastructure that you have to innovate much more rapidly. It helps the DBAs themselves increase their skills, level up. It allows teams to focus on developing software and applications that help the business innovate. Next slide, please. Additionally, AWS also has the widest array of purpose-built analytics and database services. These allow customers to enable specific use cases. For example, if their use case for an Exadata is solely around data warehousing, then they can consider migrating to a service called Redshift. On top of that, we can bundle interactive analytics using AWS Athena for reporting purposes. We also have multiple purpose-built databases like DynamoDB for key value type use cases, DocumentDB for document type use cases, a ledger-based database for immutable use cases where we don't want that data to be modified. For additional performance, we also have Elasticache as well as time series and graph-based databases. We also offer fully compatible purpose-built databases for open source versions like MySQL and PostgreSQL. And these capabilities allow us to enable the creation of a data lake, which allows multiple types of databases to access data across the entire enterprise. Next slide, please. And the way we enable migrating away from Exadata is by using a turnkey, tried and tested three-step approach. This involves using what we call an assess phase, where we do the due diligence around your Oracle environment, the performance, the metrics associated with CPU usage, storage, I/O footprint. We also build a total cost of ownership report using a directional business case. We offer complementary value-add services like database lunch and learns and immersion days around specific AWS purpose-built databases, and offer complimentary briefings and workshops as well. That allows us to then move on to the mobilize phase, in which we do a more detailed discovery and planning around your entire footprint, taking into account the additional costs of running Exadatas on-prem, such as the overhead with facilities, the power and cooling. We also build a migration plan for you and also help you enable a customer cloud center of excellence so that your team can be upskilled on new additional capabilities. We also focus on the infrastructure by helping you create appropriate security and compliance capabilities and landing zones for the right types of RDS instances that will match what you have on Exadata. That then allows us to move to the migrate and modernize phase, where we create multiple work streams for different tiers of workloads, depending on whether a customer wants to migrate a test dev environment first, for example, or a certain application or a certain line of business first. And these work streams can be kicked off individually or in parallel. And this tried and true tested approach has been used for thousands of customers and helps you increase the speed at which you can migrate away from Exadata. Next slide, please. We also offer multiple tools and programs to help you migrate away. One of those is the Optimization Licensing Assessment, also known as the OLA. We also offer migration tools to analyze your environment called Database Central State Investigation, a complementary schema conversion tool, as well as a holistic program called Database Freedom, which does an in-depth analysis onto your current architecture, your Exadata use cases, helps you determine the right type of database to migrate to, as well as a complementary service called Database Migration Accelerator, or DMA. We also partner with our professional services, and through our partners offer value-add services that help customers migrate away from Exadata. Next slide, please. So focusing on the optimization licensing assessment, a little bit more detail, that allows us to identify what the current Oracle footprint currently is. How many actual processor cores are you running Oracle on today? What paid options are turned on for those underlying processor cores? And also additionally, using detailed CPU utilization data and storage data to recommend the right types of instances for you to select when migrating away from Exadata. It also allows us to look at the underlying cost associated with an Oracle footprint, such as you may have multiple term licenses that are spread across multiple years. You may have multiple Oracle CSIs that contain multiple overlapping products that could be consolidated. You may have, multiple ULAs or perpetual use licensing agreements that, may confine you to a certain type of workload or upgrade path. That then allows us to create a TCO based on right-sizing your footprint for performance, for growth. It helps you get away from that vendor lock-in and allows us to make the right recommendations around rehosting or replatforming your Exadata. You may want to consider a lift or shift. You may want to consider moving away to an RDS, fully managed database like RDS Oracle, or even another transactional database like Aurora PostgreSQL. Next slide, please. So focusing on the tools, a very powerful complementary tool is DBCSI, or Database Central State Investigation. It allows us to look in depth at Oracle AWR data that's natively generated by the Oracle database and determine how heavy the usage of smart scans are in a specific Exadata. It allows us to do that by looking at specific variables like cell physical IO bytes eligible for predicate offload, which then allows us to identify the right type of RDS instance type, the monthly cost associated with that, as well as the pricing plan. For example, a 1-year, no upfront reserved instance pricing plan. Next slide, please. We also offer complementary services like the DMS, the Database Migration Service, which allow us to recommend the right instance types for your on-prem Oracle environment onto AWS RDS for Oracle, or, for example, refactoring an environment, a database environment, to Amazon Aurora. The schema conversion tool allows us to look at your Oracle database in more detail around the amount of stored procedures you have, the materialized views you may have. That gives us an idea of how to best approach a migration away from an on-prem monolithic database. Next slide, please. Another complementary program that we offer is Database Freedom. This allows us to offer a holistic approach on advising customers around migration strategies, selecting the right database tool, selecting, putting together the right business case around ensuring that the migration occurs in a timely and cost-effective manner. It also allows us to share migration expertise from the thousands of customers that we've helped migrate away from on-prem Oracle environments. The DMA, or the Database Migration Accelerator, is another program that's complementary that allows us to look in more detail around the databases that you have on-prem and how you can potentially refactor them to a purpose-built database like Amazon Aurora. And our DMA team provides complementary services on analyzing Oracle data through the schema conversion tool, as well as how to best convert that onto AWS RDS. Next slide, please. So to summarize, the key benefits of migrating away from Exadata are not just building a foundation that allows you to autoscale, to consider modernized purpose-built databases, to allow you to compete with other companies that have, that are able to innovate at scale, but also allows you to use the tens of hundreds of AWS native features and capabilities that allow you to transform your business and not necessarily rely on a legacy monolithic database. We're also able to help you move away from a traditional CapEx model where you're essentially purchasing hardware, purchasing storage, purchasing switches, and moving away to a model where you pay as you grow. That also allows you to use, avoid vendor lock-in. You're not locked into purchasing the next version of Exadata. You're not locked into a licensing agreement that's very rigid, and allows us to right-size performance based on your requirements, based on your growth, based on additional capabilities that your company may purchase, for example. Next slide, please. There's multiple resources available online, which we'll share with you as well. And there's multiple white papers as well. Thank you. Next slide. And so to summarize, there's a couple of different pathways on migrating away from Exadata. We can do what's called a lift or shift to EC2. We can use native Oracle tools like RMAN, for example, or use the AWS DMS service. There's some great white papers available that showcase this approach. And in this scenario, you can also use Active Data Guard, for example, and have your primary in one AWS availability zone, as well as your Data Guard or Active Data Guard standby in a second availability zone, similar to what you have on-prem today. Next slide, please. Additionally, there's capabilities and white papers on using Oracle tools like Data Pump to migrate away from Exadata to AWS RDS for Oracle. And in this, you can also use DMS for this as well. And in this case, you can transpose your data temporarily to an S3 bucket where we can store files for loading onto an RDS environment. Next slide, please. We can also help you migrate a database or a portion of the database if the use case is OLTP to an asset compliance database like Amazon Aurora. And in this case, you can create multiple read replicas. You can create an Aurora cluster, essentially, that allows you to scale based on the requirements of your overarching applications. And there's some great white papers and some great playbooks on how to do that as well. Our DMS capabilities also allow you to do object mapping to consider a purpose-built database like DynamoDB as well. Next slide, please. And if the use case is purely OLAP, so purely online analytical processing, then a portion of that workload on an Exadata can also be migrated to a purpose-built analytics service called Redshift. And we can create a Redshift cluster, which can scale for you based on the workload requirements that you have, as well as use the SCT, or the schema conversion tool, in a specific capability called the extract agent, which allows you to use multiple work streams to migrate that data away from Exadata. There's also some prescriptive guides on migrating to Redshift with DMS, as well as some great white papers, which we'll share with you as well. So to summarize, I wanted to share some of the capabilities, some of the use cases around migrating away from Exadata, and some of the reasons why you would consider doing that. And with that, I'll pass it on to our colleague, Peter, and be happy to take questions in the chat. Thank you.
Hey, good morning, everyone. This is Peter Santos. I'm a database specialist with AWS, and my team and we help customers figure out their database strategy into the cloud. Just quick, a little bit about my history. I have worked with Exadata in the past for many years. I deployed about a dozen or so myself, and then worked for Oracle for a little while on various Exadata things. So one of the things I want to talk to you guys about today is how to think about Exadata migrations. There's a couple of focus areas that we look into when we talk to our customers about Exadata. So I want to dive into a couple of those areas because hopefully they will help you figure out sort of a mental model to think about how you might approach an Exadata migration. Next slide, please. So we always try to understand, why our customers are using Exadata. Sometimes, the people we're speaking to don't have a history. They're newer to the company. They weren't there at the beginning. But generally speaking, initially when Exadata first came out, it was a data warehouse appliance, primarily targeted to OLAP and data warehouse workloads. Over time, Exadata was Oracle added flash cache and faster drives, and so it became you could use it for transactional processing. And then with the benefits of Oracle RAC, which typically comes with a lot of the Exadata implementations we see, you can kind of split your workload. If you had a 4-node, a half rack, you could split some of the nodes for your LTP system, and then the other half for your transactional system. So Oracle RAC with Exadata gave you that flexibility. And ultimately, what happened was that Exadata was marketed more as a database consolidation platform. You had a lot of standardization. Whether you worked with 1 or 10 databases, the standardization was there. It was co-supported by the customer and Oracle, so it made things very easy. And I think the database consolidation use cases is some of the ones we see more often than others, because it's typical for us to look at a customer Exadata implementation. We'll look to see 7 or 8 databases, and then we'll go through them to see which ones have the different workloads. But generally speaking, consolidation is one of the more common use cases that we see. So we try to understand the genesis of why customers are using Exadata. And more importantly, we try to understand how did that sort of meets and services the business needs. And then we use that to think about, okay, what would a typical end state architecture might look like? So reflect on your current Exadata implementations, figure out what kind of workloads they support and how do they service the business, because that will help us figure out sort of the next steps and what an end state architecture might look like. Next slide, please. So it's very rare that we talk about Exadata implementations in the cloud without talking about Oracle RAC. Oracle RAC is one of those things that we need to understand why customers are using Oracle RAC. Not every database needs Oracle RAC, but if you're consolidated on an Exadata, you probably get it by default. It gives you some flexibility. Many of our customers will adopt Oracle RAC for high availability purposes, right? So the ability to recover from a server outage, the ability to get up quick to restore that database connection. So that's one of the things we probe in a little bit when we're looking at different workloads. Do you have to have a sub-second RTO for this particular database? The other one is horizontal performance. We do see this a little bit. Any one given server is just not enough to process the workload, right? You need to sort of distribute out the workload. So this is another reason why customers will adopt Oracle RAC, and we'll probe for that and take a look at the distribution of the work across the different nodes in a cluster. And the other reason why customers will adopt Oracle RAC is for sort of the operational management capability, right? Rolling patches, the ability to distribute, workloads between one node and another node. Again, these kinds of capabilities, you get a lot of this in the cloud because of all the orchestration and automation that AWS has put forth. You get a lot of these operational flexibilities depending on which services you adopt. Now, in AWS, we don't offer Oracle RAC as a standard service, as a typical service, right? Now we're looking to make some changes there, but today we don't offer that. So customers have a couple of options, right? And as we dive into the workload, we decide, well, you could adopt EC2, right? You could move your workload to EC2, as Satya mentioned. There's lift and shift options and things of that nature. You can bring your workload to the cloud. You can adopt Oracle Data Guard, and it's not quite, you don't have quite the RTO as Oracle RAC. But again, it's an option that customers can consider. We've seen customers who are very fluent in Golden Gate use that. They use the AWS infrastructure that has multiple availability zones and sort of use Golden Gate to replicate maybe their data 3 ways and to have even higher availability. And then we also have a managed service, right? Our managed services, we use multi-AZ. And when we have a database in a multi-AZ environment, under the hood, we were actually doing block level synchronous replication from a primary node to a standby node, right? So if we're doing synchronous replication, your RPO is going to be 0, right? Because the transaction has to commit in both places. But the RTO in a multi-Z is seconds to minutes, right? It's not quite as speedy as Oracle RAC. But again, depending on what the workload is in your database, especially in your Exadata, especially if it's a consolidation environment, it may just do the job. And again, we have many customers running in the cloud who've moved away from Oracle RAC and are using the multi-AZ capabilities that we offer. Now, as I said, we don't offer the Oracle RAC today, but we have been working on something over the last year, and we're looking to make an announcement later this year at reInvent, which will provide a higher availability option. So I encourage you to be on the lookout for that messaging. Next slide, please. So the next area that we dive into a little bit is the I/O profile of a database, right? As we are looking to figure out the end-state architecture, there are things that we're going to look at very deeply. One, obviously, is that we look at an AWR report. We look at the distribution of reads to writes. If it's a read workload, we have things like read replicas in the cloud that could satisfy that. If it's a write workload, we want to understand what the writes look like. We look at the difference between the different kinds of reads. If you have buffer reads versus direct reads. Buffer reads, we have AWS provides a long list of instance types with different CPU to memory ratios. So you may need a database that has a 100 gigabyte SGA, but doesn't require a whole lot of CPU. And so we have those capabilities. We have the capabilities to have smart flash cache, similar to what's available on Exadata, where you can extend the SGA into SSD type cards, disks. So we look at that, right? And if you have a lot of direct reads, we know typically are going to see a lot of smart scan activity that we need to sort of dive deep into that. We'll look at things like commits per second, redo log generation per hour. Those are things that are more like, we look at those things to determine the type of storage configuration we should be looking at, and also looking at different migration strategies, right? If you're generating 500 gigabytes of redo log changes per hour, versus 10 gigabytes of redo log changes per hour, that changes the way we sort of approach a migration, a switch over, cut over type scenario. We'll look at the Exadata features specifically. We'll look at HCC, storage indexes, and smart scans. You can see on this particular AWR snapshot that this was I think this was a 30-minute snapshot, and you can see that in the second column to the right, that there was about 13.7 gigabytes of throughput generated on this particular snapshot. and 13.1 gigabytes of that was specific to the Smart Scan, right? So the 13.1 gigabytes of Smart Scan, it's not a small number. So it's something that we need to dive deep into to figure out what that is and why that's there. If you move on to the next slide, please. And when we look at the AWR report, we can see things that pretty much stick out, things like this: parallel hints, full table scan hints. And then we dive into a little bit of the SQL to figure out why it's there. Why is it not parallel 10? Why is it not parallel 2? Was that just a quick and easy fix? And generally speaking, when we're looking at Exadata migrations to the cloud, we do recommend that customers spend some time on a tuning effort, because that can really lower the utilization. And again, it's a more cost-effective architecture in the cloud if we can lower that utilization a little bit. Next slide. So AWRs are a point-in-time snapshot, right? 30 minutes, 1 hour, depending on how you have your AWRs configured. So as Satya mentioned, we have a tool, and we can give you a script that basically pulls AWR metric data for the last 30 days, right? So if you have 30-minute snapshots, we're capturing 1,440 AWR snapshots of data, where we're capturing a lot of data with a very quick script. It takes no more than 30 to 40 seconds to run the script. It just pulls AWR metric information, and we collect that. We load that into our tool. It provides a nice graphics and visuals about the different peaks and valleys of your workload. And here you can see that while the previous AWR showed 13.1 gigabytes of throughput, and this was sort of the May timeframe, you can see that it went up to 30 in early June, and then to 19, and then sort of back down to 30. So we want to make sure we capture all the peaks and valleys of your workload. And then one thing I want to call out here is that when we're looking at when customers are thinking, well, if I have to optimize some SQL, how much effort is that? Well, one of the things we've seen is that whether you're pushing 30 gigabytes per second of throughput or 13 gigabytes per second of throughput, the amount of tuning effort is not linear, right? Because generally speaking, there's maybe a dozen or so statements that are need to be tweaked a little bit. And if you run those statements at a concurrency of X, you might be pushing 13 gigabytes of throughput. But if you run at a higher concurrency, those same statements, now you're pushing 30 or 40 gigabytes per second of throughput. So just because you have a high number or a low number, the amount of tuning effort's not always double or triple the amount. I want to make sure that I convey that. Next slide. Okay. So so Satya talked about this DBCSI tool, this analysis tool that we have. Not only do we look at these Exadata metrics, but we look at we come up with some ballpark pricing for you to sort of help you understand kind of where the ballpark is of things. We take a look at the storage configuration that maybe we want to recommend. We also take a look at things like the amount of PL SQL code that's in a database, right? So for example, if you have a database that has 1,000 lines of PL SQL code, using some of our tools, we might be able to convert that to Postgres, for example. And if you don't have a lot of PL SQL in a database, maybe a migration to an open source engine is a good possibility. That's one of the strategies that Satya talked about. So again, we take a look at the amount of PL SQL code. We take a look at what features you're using, right? So many of our customers are not using all the enterprise features, but they just happen to deploy a bunch of databases on an Exadata. And so the majority of them may not use all the enterprise features. So we take a look at that. And if you're not using the enterprise features, we say, well, what would it look like if we try to run this on standard edition, right? This is one of the strategies that customers can evaluate to see if they can save some dollars on their licensing and sort of maybe reduce their costs. So again, the tool is very flexible. It's very easy to run. We can come back to you in just a couple of days with some output, and you kind of get an assessment of where you stand. Next slide, please. This is just, again, a screenshot of the tool. We have different algorithms in our tool that determine, how we want to make recommendations. So in this example, we took a look at all these AWR reports. We took a look at the P99 values of throughput, and we took the averages of those P99 values. So you can see here that the big peak is about 154 gigabytes of throughput, which is a pretty big number. But generally speaking, 99 gigabytes per second of throughput is what the P99 value is. And so we'll make that recommendation. We'll call that out. But again, as I mentioned before, generally speaking, you would want to look at some optimization instead of just lift and shifting that to the cloud to just make sure that you're getting the best economics out of your migration to the cloud. Next slide. Again, this is another screenshot of our IOPS. Again, here you can see we've made a suggested IOPS here is 109,000. Again, this is something that we can support in the cloud, but again, we always want to make sure that is there room for optimization? Is there room to making, we always want to make sure that we're providing the most economic, most efficient architecture to our customers. So we do want to dive into that and to see if there's any room for optimization there as well. But again, we can give you a lot of feedback with these screenshots, with these discussions. We can give you a lot of feedback so you kind of know, figure out what you want to do next. Next slide. We'll talk about a couple of customer success stories. The Australia Financial Group, this is a group out of Australia that does mortgage aggregations. So essentially, they process a lot of their home loans in Australia. This customer was running an X2-2 quarter rack. They were running a Siebel CRM system. And again, Siebel CRM systems, typically the majority of that workload is transactional in nature. So what happened was that they were running this Siebel system, and their infrastructure costs, cooling, powering, all those costs were a large percentage of their budget. So they were looking to kind of optimize, reduce some costs, and they were able to make a migration to the cloud using our RDS for Oracle Managed Service. This is the service that they moved from rack. They were able to move to a multi-AZ configuration with a synchronous storage replication under the hood. They were able to save some dollars there, and they reduced their costs quite significantly, and they were able to actually take those cost savings and augment their development teams. Next slide. So Apps Associates worked, Apps Associates worked with Pearson. Pearson, they consider themselves the world's global learning company, right? They provide learning services to individuals, institutions, and governments all over the world. So they had this very complex Oracle apps environment. They had e-business, they had OBIE, a number of different apps. And so they were looking to sort of simplify their deployment. They were looking to reduce their costs, right? They were actually in Oracle's managed cloud environment, but the costs were growing incrementally every year. They were actually not just looking to do an Exadata migration, but they were looking for a strategic partner, right? And so we always tend to think of Exadata when we're doing these things, but the reality is that Exadata is just one small piece of an overall larger strategy. And so this customer was looking to understand, long-term strategically, what is the best option for us? And they realized that after evaluating a number of providers, they realized that AWS had the most maturity. And so with the help of Apps Associates, they were able to migrate this complex apps environment to the cloud in just a few months. And they decided on using Amazon EC2 with NetApp storage volumes. The NetApp storage volumes gives the customer, snapshot clones and flexibility, something that they didn't have before. So they got some additional capabilities there by moving to AWS, and they were able to reduce their costs, but also improve their supply chain processing by 20%. So it was a much more complex environment. But again, Apps Associates does a lot of these, and this is kind of their bread and butter. So that's it. I think that's my last slide. I think if we move on to Q&A at this point. Thank you for your time. Thank you for listening to us, and we'll open it up for Q&A.
Thanks, Peter. This is Carla. We did have a question come in. What is the cost and how long does the assessment take?
Yeah, so let me take that. This is Mihir. So we typically start off with an optimization license assessment. And that's a complimentary service that Apps provides for our customers that are considering moving their Oracle database workloads to AWS. It's complimentary, but the time and duration varies based on the number of databases. So typically on an Exadata, you can take anywhere from 4 to 6 weeks because it's typically a hyper-converged database environment. Typically those customers aren't running just one database; they're running several on a Exadata platform. So we have to look at all those to determine the right sizing and licensing optimization for that.
Great, thank you. We had one more. What type of Exadata workloads can be migrated to DynamoDB?
I can take that. Yeah, so a DynamoDB is a key value store, right? A lot of the access patterns for DynamoDB are what would be equivalent on an Oracle database as index-based lookups, index range scans, index unique scans, right? So those kinds of access patterns, if you have a lot of that, and those exist in transactional systems, right? So if you have a lot of those kinds of access patterns, key-based access patterns, those translate very well to DynamoDB. So there are customers that say, you know what, we're going to take a fraction, or we're going to take this module or this capability of our application, and we're actually going to migrate it to DynamoDB, right? DynamoDB has large scale. It can be sized up and down as needed. It's very much hands off to a lot of our customers. So if a customer has a lot of key-based access patterns, index range scans, index unique scans, those kinds of patterns fit really well within DynamoDB. And DynamoDB doesn't have execution plans or anything like that, so there's not a lot of tuning involved. So it's an easy way to offload a lot of I/O to something that's just a little bit easier to manage. Hope that answered the question.
I think so. And there was one about a link, which you can see in the chat. It did have to do with what is the document link for Exadata to DynamoDB migration. So that's in there. And then we do have just one last one. How do you translate smart scans into AWS running on RDS Oracle?
Yeah, great question. So what we do is essentially look at the Oracle AWR data in a little bit more detail using the complementary tool like DBCSI. And we're able to give you guidance on whether it makes sense to potentially have additional SQL that needs to be run, right? So your smart scans are essentially offloading the SQL to the Exadata storage software. And when migrating away from Exadata, we need to recommend if there's additional indexes, for example, right, that need to be, construed onto the database, or additional ways to give you the same performance that you can get from and the smart scan capability to meet your SLAs. So definitely start with the Oracle AWR analysis using the DBCSI tool.
Okay, and then follow on, what do we use as a substitute for ASM disks?
So go ahead.
Yeah. So in terms of ASM, right? So if you're using Rack, and you can still use ASM if you want to. Alternatively, you can look at FSX for NetApp ONTAP as an alternative, and not use ASM. So your choice. If you want to use ASM, we can configure it with ASM. If you don't want to use ASM, we can move it to NetApp ONTAP. It just depends on what kind of operational efficiencies you're looking for.
Okay, and then can you comment on maximum utilization in terms of average throughput, IOPS, that can be managed on RDS? Also, do you have success stories for managing SAP application DBs on RDS?
So on the note on the max utilization, right, there's maximum storage allocation for specific instance types. There's specific ranges of how much vCPU, how much memory is allocated to each RDS instance types. So what we typically do is notwithstanding the new instances and the new capabilities that are released every so often, but look at the data in a little bit more detail to identify which is the right fit in terms of the right instance types that gives you the CPU utilization, the throughput that you need. And the DBCSI tool also gives us the capability to recommend the next adjacent best instance type as well. So if your workload doesn't fit in instance type A, then we recommend instance type B and C. And that's an automated recommendation engine that the tool gives you.
Okay.
And thanks. And on the SAP front, we'll share some best practices and links in the chat as well. Thank you.
Yep, there was one follow on to that too. Any specific SAP applications that are good fits for RDS?
We'll go ahead and share. So we definitely can run. We can migrate SAP Adaptive Server to RDS using AWS DMS. And then there's specific use cases around SAP that we can share with you as a follow-up.
Okay, and I think we have time for one more. Just see here. Do you recommend NFS or ISCSI for FSX NetOp ONTAP? What's your experience with these terms of stability and performance?
Yeah, so we're actually working on a 128 terabyte Exadata migration to AWS, and the entire application and database architecture is being architected on NetApp ONTAP. We're looking at iSCSI for that solution. So you have to balance not only just whether it's NFS or iSCSI, et cetera, we have to balance that with the client's business requirements, right? IOPS throughput, this, RPO, RTO. What do they need that system to do, right? So it's a holistic approach to determining what's best from that perspective in terms of how the customer wants to operate that platform, if you will. But for these larger, like 128 terabyte systems that we're migrating, we're using iSCSI.
Okay. And then this is the last question is, do you offer complementary POC migrating from Exadata to AWS using just one database?
So we definitely offer complementary analysis, definitely complementary assessments, complementary workshops. And those essentially allow a customer to help you evaluate, whether you should migrate that database, Exadata database to RDS Oracle, for example, or a purpose-built database. And there's a number of complementary programs and offerings that AWS has in this regard. In fact, we're working with a customer right now where we're doing a complementary 2-day workshop on identifying their Exadata patterns and identifying the right types of instances, not just for their database, but also for the overarching application servers. Thank you.
Okay. Great, thank you. So here in terms of next steps.
So in terms of next steps, if you have an Exadata workload or any Oracle application database workload that you're considering migrating, or if you had any doubts, hey, can I migrate and operate that system on AWS successfully, reach out to us. We have complementary optimization license assessment, right? We'll take a look at that system for you. We'll right size it in AWS, make sure your Oracle licenses are optimized on that target architecture solution for you. So there's a link to that in the AWS marketplace as well. And then if you're also interested, you can download the Exadata ebook off of the Apps Associates website as well. That'll talk about in detail some of the things like Peter spoke about today on the session today. So if y'all have any other further questions or thoughts or comments and want to deep dive, some stuff further, feel free to email me and or call me, and happy to hop on a call, whether it's, hey, we're trying to migrate a large Exadata platform to AWS and, iSCSI or NFS, ASM or not. What do we recommend? What do we see? How do we optimize that? Happy to have that conversation.
Great. Well, thank you so much to everyone who joined us today and our presenters. We appreciate your time. Have a wonderful day.